general study of the mechanical oscillation. So we'll talk now only qualitatively here about what's happening to the object when it's moving with oscillation motion. So let's suppose we have a horizontal pendulum spring, and then this we have oscillation of this pendulum. So when the block is displaced to the right of equilibrium, the force exerted by the spring acts to the left. This is what we call the force of the spring, and this is what we call the tension. While when the object is at equilibrium, then there's no tension, there's no force exerted on M by the spring. And when the block is displaced to the left of the equilibrium, the force will be exerted on the spring will act to the right of the figure. Now, we shift the solid S from its equilibrium position by xm bigger than 0, and then we release it. So we'll study this case and we'll explain what will happen. So this is the origin, and we elongate it by xm bigger than 0. So the 0 here, and this is xm. And then we will notice that we will have oscillation. So كمان رح تعمل to the minus xm here. Now the question is, what's happening to the speed also? So what's happening to the to x, and what's happening to the speed? If we notice, and this is the x-axis, so if we notice when an object hiked to the right, okay, when we elongated to the xm and then we release it, we'll notice that the speed here, so v here is equal to 0, release it. As the object moves to the left, the speed will increase, but the speed will increase in the negative direction. So when the object moves to the left, the speed will increase in the negative direction until reaching the equilibrium position. At the equilibrium position, I will have the maximum speed. V is maximum. And once again, the object will continue its motion to the left, but we'll notice that the speed will decrease from a maximum value to V equal to 0, but will decrease in the negative direction. Then another time, when it's maximum compressed, and then the object will continue its motion, so رح كمل بهذا الاتجاه, V was equal to 0, so V here will increase in order to become V maximum, but will decrease in which direction? In the positive direction. So here V will be positive, and then it will continue its motion. Also, V is positive, but V is what? The value is decreasing then to become equal to 0 at the maximum elongation. This means if I want, for example, to represent X and V in terms of time, then I will notice this is X in terms of time. So نلاحظ, for example, here بلش من maximum, and then, okay, so this is the maximum xm, and this is the equilibrium here, and then رجعت راحت على minus xm. Now what's happening with the speed? If I want to explain what's happening with the speed, so I can trace it here. So when the object was at the maximum elongation, the speed was equal to 0. بس مش بدي اطلع هلا okay, the speed is equal to 0 بطلع ولا بتنزل. How do I know? If I look at the figure here, the speed is increasing, but it's increasing in which direction? It's increasing in a negative direction here. So this means this will be V in terms of time. So it will increase in the negative direction until when the object is at the equilibrium position, the speed is maximum, but it's maximum in the negative direction. So this is V. And then once again, when it reaches the maximum compression, minus xm, the speed will become equal to 0. And when it comes back, okay, and at origin, we have a maximum value of the speed, but now the speed is increasing in the positive direction until reaching a value at origin, equilibrium, which is maximum. لما بتصير الX maximum, so the speed will become equal to 0, and that's it. So this is X in terms of time, and this is V in terms of the time. Here I can say that we did a general study of the oscillation of the pendulum.